Good morning. This is Tim Hember from ThinkRF, and I thank you for attending our webinar. I have Nikhil Adnani, the CTO of ThinkRF, and Steve Rosinski for sales here. What we're going to be doing is basically, as mentioned in the webinar invite, we're going to be basically overviewing our product, which we've advanced significantly over the last year, and basically introducing our new R5500 and the application, the spectrum analysis application, the S240, and also just talking briefly just about our foray into the 5G space, what we're doing with regard to that, and some applications that would be pertinent to specifically the federal government. So with that, I'm going to hand this over to Nikhil. Go ahead, Nikhil.
Yeah, thanks, Tim. Good morning, everybody. So today we'll be talking about ThinkRF's real-time spectrum analysis solution for monitoring, in particular, of wireless devices. As an overview, we'll be covering two very specific product areas. The new product that we released last month, the R5500 Real-Time Spectrum Analyzer, and the S240 spectrum analysis software that goes along with it, solutions, applications, and the benefits of our products, which will be followed by a Q&A session. So our value proposition is a compact, headless, remote deployable real-time spectrum analyzer representing the fourth category of instrumentation that provides the performance of a traditional analyzer at 1/10 the cost. So this is an SDR analyzer that is interfaces with a laptop or a thin client that is used to display modern waveforms that have been analyzed on the hardware for a number of different applications in federal government and aerospace and defense, manufacturing, and service providers as well.
Yeah, and I apologize just to jump in, but one thing I forgot to mention is that we'll take questions. You can type them in via the dialog box in the on the webinar, the GoToMeeting webinar, and so we'll take those questions, and we may or may not, depending on the context, we may or may not defer those questions to the end of the session, and we'll be dealing with questions at that time. So sorry, Nikhil, but go ahead.
Yeah, thanks. I know that's a good point. Thank you. So in terms of our spectrum analysis platform, on slide number 4, we've got this slide describes the architecture of the product from the hardware all the way up to the software application layer. At the hardware level, we have a highly configurable SDR product. Enables full frequency range, so we cover from 9 kilohertz all the way up to 27 gigahertz in one box. And we provide support as well. We provide support for interfacing that radio front end with third-party high-end digitizers for RF streaming applications as well. Moving up one layer, we have a digital section, which is includes real-time digitization and signal processing in the hardware with GIGI interfaces, which are designed for efficiency. Moving yet another layer up, we have a very powerful set of APIs with a common framework such as Python, C, C++, MATLAB, and LabVIEW. As well, we enable control using traditional mechanisms like Skippy, and the data that's received is in beta VRT format. So that's a very commonly used software radio format. And finally, moving up to the application layer, we have a S240 real-time spectrum analyzer application, and we also support a number of third-party analysis applications. In terms of moving ahead, in terms of our product vision and direction, we're moving from 27 gig that we have today to 30 gig and beyond for the analysis of 5G signals that are expected to be in place by the year 2020. Obviously, we'll have this capability well before that time frame. In terms of our spectrum analysis, we support 100 meg of real-time bandwidth. We're moving to 200 megahertz and beyond, once again to satisfy wideband formats such as 5G. In terms of our APIs, we currently have a best-of-class API with support for a number of different applications, and moving yet up another layer in terms of our applications, we are actively integrating with a number of third-party spectrum analysis application providers in the monitoring space, R&D, and manufacturing as well. And all these applications help to, in terms of developing our capability, adding more value to our product for areas such as signal demodulation and further analysis.
I guess while we're in here, one of the questions posted was asking about real-time capture bandwidth, phase, noise specifications, and typical DANL. I know it's drilling in a bit, but
yeah. So in terms of our DANL, our product has a DANL as good as -160 dBm per hertz. So that's a market-leading spec in terms of when you compare that with benchtop spectrum analyzers. In terms of phase noise, Tim, was that the question?
No. Yeah, sorry, phase noise specifications.
In terms of phase noise, our products are very consistent with, for instance, the Keysight's C-series analyzers. We've actually done some benchmarking in that area and are happy to provide that to interested parties. This slide goes through the 5500 Real-Time Spectrum Analyzer. It's a small form factor, so the size of a laptop, headless and PC-driven. In terms of its capability, it has a gigabit Ethernet networking and can be remotely deployable anywhere in the world and accessed anywhere with a network connection. The product integrates the SDR receiver with the digitization, real-time digitization and signal processing in the hardware, and which can be complemented by further signal processing in your software application or in the S240. In terms of the frequency ranges, we've already covered this, but at a very high level, 9 kilohertz to 27 gigahertz, real-time bandwidths of 40 and up to 100 megahertz in direct conversion. And using external digitizers, the bandwidth can be extended to 160 megahertz. This slide shows the interfaces that are available of the R5500, the RF input, and also the analog outputs that can be used to interface with digitizers, and 10 meg in and 10 meg out for synchronization of multiple boxes for applications such as direction finding. This is an overview of where we were with the WSA 5000 and where what we've achieved with the 5500. With the 5000, our sweep rates were 6.5 gigahertz per second. We've gone up to a market-leading 28 gigahertz per second. Our stream rates, which is a measure of how well we can stream data across the gigabit Ethernet interface for applications like demodulation, real-time demodulation. We've increased that from 32 megabits per second to 360, so of over a factor of 10. In terms of the frequency ranges, we're down to 9 kilohertz from 100, and in terms of the step attenuator, we've increased the granularity as well as calibration accuracy at 4 different steps. And this is useful for real-world operating environments where sometimes signals can be weak and strong at the same time, so to provide that level of control to prevent saturation of the receiver. And finally, in terms of the maximum input level for the 8 gigahertz product, we're up to plus 20 dBm, and the analog output is now a standard option in all our products. Moving on to the S240 real-time analysis software, the interface has been enhanced. We've gone from our Rev3 real-time spectrum analyzer application to what you see on your screen. It features standard controls, and in terms of its real-time capability, also waterfall, persistence, and other visualization tools, and also provides the ability for real-time triggering, recording, and playback. The user interface is consistent with existing products out there, so the learning curve is shortened dramatically as a result of that. In terms of the enhancements, we had restructured and improved the UI, provided new enhanced capability, specifically in terms of adjustable resolution bandwidths and video bandwidths. And also in terms of measurement tools, we provided more mouse control for more immediate feedback in terms of signal peaks and signal bandwidths as well. In addition, we've improved our data storage capability. That's important for monitoring applications, and we also save things like markers and settings.
While we're on the S240, there's a question about demodulation.
So currently, demodulation is on our roadmap. We're going to start with some basic AM and FM demod capability, and moving into the wider bandwidth like 5G. So we'll be providing all that capability from within the S240.
Actually, while we're still on this, and we're talking about both the hardware and the software, there's also a question about how we ensure amplitude accuracy.
So our amplitude is, there are a couple of aspects to that response, and one of them is that we calibrate our products in our factory over 4 different amplitude settings, as well over temperature as well. And in addition to that, we also provide mistraceable calibration, and our specs for the R5500 are plus or minus 1 dB amplitude accuracy. Okay, moving on to capabilities for applications. So this shows you what product family, what product variant in terms of frequency range and what bandwidth you require for any specific applications, ranging from 5G to OEM integration. One aspect of the product that we haven't touched on here is the fact that our product is, on account of its form factor, has been integrated in a number of applications for R&D as well as all the way through monitoring. This slide touches on 5G. As we know, 5G is emerging. It's service providers are starting to put in initial pre-standards deployments, and so ThinkRF is at the leading edge of providing test capability for those applications. And it's anticipated that while there are a number of deployments that will be in the sub 6 gigahertz range, most of the target applications and bandwidths are applicable to higher than 20 gigahertz. So we likely see applications in the 30 gigahertz range, and with bandwidths in excess of 200 megahertz, going up to 1 gigahertz. And our product architectures are scalable and well suited for the analysis of 5G waveforms. This slide, moving on to the next slide, we work with a number of third-party technology providers. In terms of development environments, most people are familiar with MATLAB and LabVIEW. We support both those. In addition to that, we support Python and C++. And what we've also taken the opportunity to mention is a number of companies that today work with our application to provide solutions to the marketplace, like Comment Consulting, PDTG, LS Telecom, and IS Wireless. Finally, moving on to the benefits of our products. what are products? As mentioned, we have a headless product that has that's distinct from the other three categories of instrumentation, namely benchtop, modular, and PXI, and handheld. The product is software defined, so it allows us to, unlike traditional instruments, it allows us to upgrade our capability in the field, which means that we can add support for newer waveforms and demodulation capabilities while retaining the existing hardware. In terms of the form factor, we have a headless instrument, and we leverage Moore's law to move processing onto laptops, which can be upgraded very easily and at low cost. And in terms of the one key aspect of this fourth category of instrumentation is that it can be used as a building block to, and you can add to this capability depending on your requirements. So we can use it for high-end data acquisition, embedded with another instrumentation, remote analysis, and also rack and network for traditional manufacturing applications. This slide gives you a visual overview of what we mean by real-time analysis. And what we do is we capture signals as they occur with large dynamic range and over long periods of time, which allows us to capture short intermittent interferers, for instance, and also frequency hoppers like Bluetooth. And so the real-time capability allows you to detect anything and everything. How does our product compare with traditional solutions? On this slide, we show you how the the traditional companies that have products out there, such as the Keysights and the RNSs, the price scales quite rapidly with bandwidth and frequency range, whereas our products offer a 10x improvement while retaining close to 90% of capability. And this slide provides an overview of the visual overview of the various deployment scenarios that our product is applicable to. And our vision really is a one-box solution for all applications, moving from R&D all the way to monitoring. And getting into a little bit of detail, this slide provides an overview of price performance and what we mean by 10x. So while our standard list price for our base product is $5,700, it compares very well with the real-time by a factor of 10 with the real-time Tektronix real-time spectrum analyzers, while providing nearly the same technological capability at a fraction of the form factor and weight.
So with that, I mean, we'll hand this over to the questions and answers, and I've got a few actually that have come in. One is just the availability of the 5500. Maybe Steve, you can speak to that.
Yeah, thanks, Tim. Everything you've heard today, the good news is it is available. We have production-ready products on the full range from the 8 gig up to 27 gigahertz products available first week in February. So if you're interested in a quotation and if you want to explore purchasing units, please send us an email and I can get back to you on that. But these are production-ready products that are ready to go. And delivery times, roughly 4 weeks, depending on quantities required. So in small numbers, we can deliver fairly quickly.
Actually, while we're on that, another question was just on pricing and whether it's changed versus the WSA 5000.
Right, exactly. Thanks, Tim. That's actually very good news. We had decided that we're going to keep the same pricing on the R5500 as we have on the WSA 5000. I think some of you may have already either worked with the product or been exposed to our pricing. So essentially, for the same frequency ranges but enhanced performance, we are not charging any more for that. And also of note, the S240, which Nikhil covered in some detail, is also included in the pricing. So it has not changed. Everything you have seen in the presentation is included in the price. On
a change of note, okay, another question is just asking about what applications and or deployments that we might have done with the federal government. Maybe Nikhil, you can speak to that one.
Yeah, certainly. So our product has been used extensively within R&D applications within the federal government. To mention specific, CRC is a customer. They've used this for spectrum research, and they continue to use it as a tool for spectrum applications. Industry Canada was an early customer for the product, and we continue to work with third-party application providers to provide solutions for spectrum monitoring within the federal government. In addition, we've been engaged on the TSCM front with third-party vendors for solutions for bug hunting and as well surveillance and countermeasures. Anything you want to add to that, Steve?
No, just that you know, a few of the slides indicated that we have partnerships which really enhance the specific application requirements of our customers, and the TSCM area I know is of interest to certain types of government departments, the security-oriented departments. So we do, I just want to make sure that everybody understands that we do have a solution to address the technical security countermeasures monitoring requirements that do come up. So we can dig into that in more detail later, offline.
Actually, yeah, just on the note of you know, availability of the product and such, and the product itself, is that it should be noted that this is a leading product in its space, and we're selling this thing significantly globally. But it is, you know, as a Canadian company, I mean, it's the only product of its kind from the standpoint of Canadian solutions.
Yeah, sorry, that's good point. And the TSCM solution we were talking about through PDTG is a 100% Canadian solution as well. Our partner is based in, our TSCM partner is based in Toronto. So I think that bodes well for Canadian success stories in the federal government.
And so that's it for the questions and for the webinar. Again, thank you very much for everyone that has attended, and thank you, Nikhil and Steve. And with that, we'll adjourn.
Thank you.
Thank you. Bye now.